Thank you, everybody, for joining us today. This is one Monday, Tuesday, okay, fourth day of the Design Research Week 2026. It's a week of events that revolves, you can guess, around design research, different ways we do research in design, and information design and data visualization is one of those areas for us to do research. I'm Paolo Ciuccarelli. I'm the founding director of the Center for Design. I'm happy to welcome all of you online, in person, and our speakers that will be introduced shortly by Enrico Bertini, the co-author of this meeting. It's not the first time that at the Center for Design and the Design Research Week we talk about AI. So we started actually with talking about AI in general as approaches and methods for design broadly, like not just communication design, innovation management, very broad conversation in 2023. 2024, we get more into data visualization. And the question was, where does data visualization fit in an AI-driven world? Melanie was already part of the panel. We had other people joining us from the area, but also from abroad for that conversation. That was 2024. 25, again, me and Enrico organizing a panel on the generative AI that became a thing last year more than previously, and wanted to dig deeper into what generative AI could do for data visualization with, again, some guests from both companies and research. Here we are today. Sorry, having discovered that article that I didn't know about, and they wrote about our meeting. You never, just yesterday I discovered that. That was we organized, so you never know what happens when you organize these things. Here we are today, again, on AI and data visualization with an incredible panel here. I will let you introduce. We set up, like, the ground is this statement that we posted a long time ago, so it was purposely very vague. So the idea is that data visualization is entering this kind of new phase with AI becoming part of the scene, not as a tool to master, but as a presence to negotiate. Maybe we can say a few words later on what this may mean. And the session wants to create space for reflecting on how visual practices may be shifting, bending, or resisting this new form of automation and intelligence. So that's what we came up with a few months ago, but that's of course open for conversation and discussion. Enrico, yours.
Hey, thanks, Paolo. As you can see, we have to organize it at least once every few months.
Yeah, once a year.
At least once a year, because things are changing so fast that we need to gather some experts to talk about it. And so in normal times, we wouldn't do that, but I think when we talk about AI nowadays, it does make sense to have frequent events around it. I'm really excited to have our panelists here today. On purpose, we tried, as in the other panels, try to bring people that come from academia and industry to try to bring their complementary perspectives. I don't know if you guys will be able to fight a little bit in this panel. We have some interesting disagreements. So I'm going to introduce them, maybe going around like this. So Richard Brath is a partner at Uncharted Software, a company that has been doing interactive analytics, data visualization for 20 plus years. And Richard has been in that company since almost the beginning. And we've known each other for many, many years. You've also done a lot of work for financial markets, many other domains. But recently, he's been publishing quite often really interesting articles in his blog post online about experiments that he's been doing with AI tools and visualization, and I've been following these experiments really closely. So it's been a lot of fun. Next to him, we have Fritz Lekschas. Fritz is also more from the industry side. He's founding research engineer at Ridge AI, building AI native tools that let users intelligently create and explore data-heavy visualization dashboards. Previously, he was at OZ, correct?
Yeah.
Again, some of his work that I'm familiar with also at the intersection of visual analytics and AI. So really, really interesting practical tools. I know that you guys at Bridge are building new things and really curious to see what is happening there. And I guess you're going to present something about it.
No.
I forgot.
Thanks.
Then we have Angie Boggust. She's a PhD candidate at MIT, so just across the river. You know, across the river feels. I always have this conversation. It's so far, but it's actually walkable and really close. But the river in our head makes it really, really far. She's been studying during her PhD again problems at the intersection of data visualization and AI. If I'm not mistaken, you have a stronger focus on alignment between what humans do or think about something and how machines think about something, and how they differ. So lots of interesting research in that space. And then we have my colleague Melanie Tory, who is the director at the Rue Institute in Portland. So there's a whole research space in Portland with many research activities, and Melanie directs the activities around the interactive data and visualization. She also has a background in industry. She spent quite some time at Tableau Software in the research team, and she's been doing work at the intersection of natural language processing and data visualization again. So all of them are really like real experts in this space, and I'm really looking forward to hearing from them. Each of them is going to give us a 10 minutes presentation about how they think about this world between data visualization and AI. And then we will follow with a few questions that we will ask the panelists, and then we will open up to the audience to ask their own questions. Okay. So maybe we can start with you, Richard.
Okay.
And for people online, if you have questions, we
Yeah,
use the chat.
you can ask.
It's moderated.
Yeah.
So feel free to throw your questions over there, and then we will bring them. Yeah.
Great. So I'll be talking about visualization design before and after AI. As already mentioned, I'm Richard Brath. My first degree was in architecture, designing buildings, and just as a way of thinking about how we design visualizations, I'm going to use an analogy to architecture. And when you build buildings in the 1800s, you're using things like stone, brick, timber, plaster, and so forth. And it takes a decade to build a building like this in that time period. When you go to 1850, you now have a transformation. You're at an inflection point, and you need this building built in less than a year, and it's 3 times bigger than any building on Earth because England has a crazy idea to host the world's biggest exhibition ever. All the traditional architects fail in their submissions, and who wins is actually a gardener who understands how to build greenhouses. And he comes with a completely different set of pieces in his design palette to work with: iron, plate, glass, bolted joints, and so forth, right? And this enables a whole new form of architecture and thinking about how you can work in the design space. And it enables things like this that come, 100 years later. Certainly there's additional things like elevators and engineers and modernism, but all the seeds of that are already in existence back in 1851 when the original Crystal Palace was built. So let's shift and talk about visualization for a moment and data visualization. And so from our perspective in industry, it's Long story short, it's already pervasive. We're using AI for everything in relation to data visualization. The data itself, what's generated from the AI can be the data. AI can help you fetch the data, assess what might be missing in the data, enriching data, and so forth. It can help you turn that data into different kinds of content with analytics like classifiers, knowledge graphs, and so forth. With visualization, it can help you design the visualizations and generate the code, and it can drive the UX and everything, right? So for the purposes of this talk, we're going to focus on AI, how it aids the design of visualization. Now, these are visualizations from my career. I've been around for a little while. And so you can see that we've got all different kinds of visualizations on here going back to the late 90s, the aughts, the tens, and recent. And these are all visualizations for expert users. These are not like consumer visualizations. These are people with deep domain expertise. And one of the things you'll notice is, yes, there's visualization, geometry, color, shapes, and so forth. But there's also a lot of text in them. In all of these visualizations, you can see a huge amount of text. And even this latest one here, and it's all pushed off to the side in this one. This one here, baseball, it doesn't have text, but it does have a lot of video. Video is incredibly important. And so what you've got are these different classes of data that aren't being visualized, right? So only certain classes of data get to play in data visualization. And that brings me into a thesis and a provocation I've been pushing for the last 10 years, which is not everything that counts can be counted, from this quote in the 60s. And that inspired me to do a PhD. That inspired me to write a book on visualizing with text, so thinking of text as a first-class citizen and how that can work in visualizations. And yes, we've been doing it for a long time in history, just not the last 25 years computationally. And the book itself has lots of examples. There's essentially two approaches in the book where I approach the design space and bringing text. One is kind of bottom up, adding text into visualizations like maps and lines and so forth. And the other way is top down, where you take text and prose and you add visualization into it, changing the bold or the color and so forth. And so there's lots of possibilities when you work with this. And that ability to explore that design space, though, is writing code. It's slow to create that code. So you can generate ideas as a designer, but then to actually try out those ideas takes effort. And so as Enrico was mentioning, I have a blog. A lot of those previous examples that you saw on the previous slide were on the blog. But I've also been using AI and LLMs to explore this design space of textual data visualizations since then. And so here's a very early one, pre-chat GPT. And this follows basically the Ben Schneiderman approach of having all of your overview first. And so Alice in Wonderland has been summarized, and the entire first chapter gets reduced to 15 sentences because each paragraph has been reduced to a singular sentence by an LLM. It could do summarization. So we get a very easy overview of this, overview first, details on demand, and all the details in there as we go through that. So that's a very simple early example of something that would have been previously impossible with AI. Now, there's lots of other kinds of things that we've got in here as well. This is an example that if there's anybody in the room who is in an MBA program, is that you have to do these analyses across diverse data sets. It's all kinds of apples and oranges comparisons. And then you have to assemble them into ways that people can understand. So you use diagrams to explain these things like SWOT diagrams, Porter's forces diagrams, and so forth. And there's a long history of these various diagrams. And so what we can do is we can actually use AI, getting all these ads in here. You can use, here's the traditional kinds of diagrams that you have, and then you can use AI to find the insights in the data, assemble those insights, and package them up in the diagrams. And so we didn't think of diagrams as data visualization maybe 5-10 years ago. Now they're completely in our purview to create these kinds of things computationally using AI. A couple other examples here. Tables are a popular thing to use to organize information. We don't use tables too much in visualization, maybe heat maps and so forth. One of the challenges with tables, for instance, if you're trying to put text into a table, you get the problem like this, where you get a lot of empty cells and some cells where the text just doesn't fit. Well, we can use AI to essentially build that very quickly and test out what it might look like if I can just simply run an algorithm on that to adjust the table to now fit the kind of data that I have. So all kinds of things start coming into the purview of what is possible for visualization when you do this. And just one last example here. This is just taking the text of Alice in Wonderland, and we're using semantic encoding. So what are the semantics? Alice goes into this topsy-turvy world. It's a little bit strange, and it gets stranger and stranger the further she's in this environment. So if you're watching, this is moving very slowly, the text itself, and shifting. But the further and deeper I go into the story, the more the text starts to bend and move in here. And so, it's getting pretty funky there when she's talking to the caterpillar and smoking, and she's talking to the cat and the hatter at the party, and things are moving a little further, and so on, right? And so we have all this wonderful stuff happening. Text. Okay, so much more is possible, and I'd like to point out, I think Enrico made the point of how quickly things are changing. The diagram on the left was 1 year after ChatGPT was released. It was at a workshop, and people were sketching ideas of how you could use AI in the future with visualization. And this one is an example of, I've just got a humanities research thing. I've got two entities. I want to know how they're connected. I just draw a line between them, and ChatGPT will automatically figure out the text and put it in there of how these two things are connected. Well, the paper itself is going to be published in 2 months. That's the speed of some of the kinds of publication. And Claude may actually do this reasonably well. We're going to try it on the fly here, but it's going to create a bunch of characters and then compute the connections between those characters. So on the fly here, Mary Curie and Hypatia of Alexandria. We just dropped those together, and ChatGPT created its own code where it runs itself when the code is running, and came back with this relationship between Mary Curie and Hypatia of Alexandria, and you can read it there, and it's on the line and so forth. So to wrap up my section here, is we can now talk about the visualization design space. We were 20 years ago just talking about quantitative data and color and size. We started realizing there was more to it. We're now able to utilize AI to really start to explore the boundaries of the space much more. And the real question is, what's actually possible now at this inflection point? We don't know. We don't have that mapped out yet. So,
Mark,
thanks.
thank you. Follow the same order?
Yeah.
Yeah. Okay.
Yeah, again, hi everyone. I'm Fritz. I work at a startup, very young startup called Bridge AI. And I want to talk a little bit more about the technical side, so about data visualization tools in the age of AI, and what the impact is that I'm seeing and how priorities really shift there. You already heard this. Yeah, I work at Bridge AI. I have a background in bioinformatics, so I'm previously really deep in like the biology side of things, and now I'm working a little bit more general. So to give you a really rough idea of what does Rich AI do, Enrico, you've basically copied that per sentence perfectly. So we are working on AI native tools to help you intelligently create and explore dashboards. What does that mean? Yeah, I'm sure. I have a little preview here, so you're the first ones to see this. So what we do is we help you create dashboards like that, but beyond sort of like the very generic thing that you can do everywhere, you have a chat, which is still text inputs, but sort of like visual output. And so you can really quickly get outputs. You see everything is interactive. So as I start mousing around, you can like interact with the dashboard itself, but you can also interact with the answers on the right side. But this is not a marketing talk, so let's focus back on the tools and what the impact of AI is. And to get there, I want to do a very, very brief recap on like what is actually the purpose of data visualization and what does that mean for tools itself. And so you've probably maybe all heard this, like the purpose of visualization is insights, right? It's not the visuals itself. And I would broaden this slightly and say like what you want from a visualization is to get an intuition for data. And specifically for the tools, you want the tools to help you surface useful information to gain a better understanding of the patterns and trends in the data. And one thing I've learned over the years building like lots of like visualization tools is that oftentimes the insight that you want to gain is very much in the details. So that could mean, for instance, you know, you analyze data, but you have a quality problem at the very, very beginning, and then you visualize something at the very end. And the real insight might come from like, oh, oops, I'm just working with wrong data. And that's an insight, but to get that insight, you need to go all the way back to the beginning, or in between. There can be like so many things that can go wrong. And the insight is sometimes at the very end for the data that we visualize, sometimes it's not. What does that mean for visualization tools? I think they need to be everywhere and they need to integrate into that whole process fluently. And they should surface useful information fast. So try to sketch this out, but the way I usually think about like when is a tool useful and what does it mean for helping you gain insights is a graph, and the x-axis is just time. So think of it like the time you spend on trying to make sense of data. And the y-axis is like a relative your rate of how much information you gain or insights. And without the baseline, it's random, of course, but the baseline here, you have some sort of like insights you gain from just like pulling up the table or doing other stuff, looking at what was actually analyzed. Then if you bring a visualization tool in, your rate all of a sudden drops drastically. Because with a lot of tools, you first need to understand, well, how does the UI work? Like which of the 2,000 buttons do I need to click? And so you're spending a lot of time trying to think of like, how do I translate the data question I have into UI operations to get to an answer? The good news often is like once you get there, right, then at the very end, you see like the rate of gaining insights much higher with the tool. Well, what if you bring AI into this? It's just my opinion, but from the way I see it, it drastically improves several different things. So first of all, I think you still have a dip, like you still need to learn a little bit about the tool. But the dip is like the friction is way less with AI. I'll show you examples. The short answer is natural language interfaces. Yeah, you don't need to, how do I translate my question into a button click? It's also way shorter because by having an assistant AI next to you, it can basically teach you, if it's aligned, how to use the tool. And then ultimately, for all the reasons that Richard already pointed out, AI can help you surface much deeper insights. In fact, the visualization tool might just show you the final layer of data, like the cleanup stuff. But there's nothing preventing AI from digging deep into like the source analysis and pointing out, hey, you're seeing a pattern here that just seems to be an issue from when the data was collected. And so what does that mean technically? So I think there are like two really big aspects that AI sort of like mean for data visualization tools specifically. So one is you can get to prototypes extremely fast, but not just prototypes. You can build out entire products if you know what you want to build extremely fast now. And there's no more sort of like bottleneck in terms of like, how do I implement this? And that was previously a real bottleneck. There's a lot of like visualization tools that I've seen lacked real world adoption because they were missing non-visualization features that Richard also pointed out to. Like there's a lot of stuff in the visualization tool that has nothing to do with visualization and everything to do with like, can the actual user efficiently. And then the second is kind of like democratized access, right? Like oftentimes data is messy and science is messy. So the tools, there needs to be complexity. You cannot sort of like make that go away. But with AI, you can just get around the complexity by having sort of like AI figure out the tool complexity. And so to have some visual stuff in here, this is an example. I always wanted to build a tool for exploring high-dimensional data, not just as a static 2D embedding, but in a way that I can think of like a tour in a high-dimensional space. I've tried to build this for years. At some point, I spent a couple months working on this. I didn't have the time, so at some point I gave up. 2 weeks ago, I just took another crack at it. After 2 days, I had a working prototype. For 2 more weeks, I polished it up. So that's the stuff that you can just do now with AI, like everyone. Still a quick hint, there's still stuff that is not solved, which is like, is this actually useful? Yeah, what kind of insight are you drawing out of this? That remains, and that is as hard as before, and AI can't really help you with that at all. Can, but like not as drastically as with the implementation. Here's another one. It's a genome browser we built years ago. The complex expert tool that shows you genetic data and has like these huge matrices. If I wanted to use this and I had no clue what's going on, I would have to spend a lot of time learning what are the submenus here? What do I need to click to this? Well, what can I do now? Like with this thing called MCP Web, for instance, I can just control my visualization, natural language interface, and not the fastest yet, but with the improvements in AI, you can be sure like in a year or so, it's like 6 times faster. But here, just built me a new view, pulled up new data, find that zoomed into the genome, into the gene that I wanted it to, and it even synchronized the views without me having to learn anything. And then I can just use it. So that's the kind of like democratization of access. You can finally use expert tools and not just sort of like after you've learned it for a long time, but like. So the bottleneck now, I think, drastically shifts from can I implement stuff to what is my domain expertise? Do I really know what to do? Like issues or troubles or challenges the users have, judgments, and also pace. Like how should that really look like? They quickly churn out like a prototype and someone doesn't feel right, and then like your own judgment and pace to make it. What does it mean ultimately? I think there's stuff like these 4 pillars have always been there, but I think they're more important than ever now when you build tools, like knowing your users, basically understanding what no. Building modular, in my opinion, is like becoming, because ultimately we already see this with chatbots. They try to suck everything in. Very soon they're going to compose interfaces for us. And if you build monolithically, they visualization tools to be used, I think they need to be composable. And you still also want to, there's still some engineering involved in implementations, maybe not it anymore. But how do you constrain a space smartly, bringing our own domain expertise into the system, because that can often lead to good and much, much faster results. And to wrap this up, the thing that I have not shown you previously, Rich AI, is how do we actually get to that dashboard? Because the hard part is not like looking around and exploring. The hard part is how you get there. And if you constrain the space of possibilities quickly, and this is in real time. So on the left side, you see little chat, analyzes the data a little bit, paste in short sentence of what I want, and in 15 more seconds or so, you have your dashboard. And you can get there also without all the constraining, but then it takes a lot longer. There's a lot of like possibilities, so like it goes sideways, which sometimes is interesting, but in a business case, you usually want to get what you want quickly. So here's the dashboard, right? 40 seconds or whatever. And it comes with like sort of like the stuff that you want baked in, like in the actions. So AI doesn't need to think. All right. And so I think sort of like to end this, I think with AI in the mix, sort of like for visualization tools, it really shifts now. Everybody can build and use. There are no more barriers really. But what still remains the same is like what actually makes a good tool. Like what is a tool that's useful? What really helps us, yeah, move the needle for data workers. That's kind of all I have. I'm curious what other people think of like now that everything is sort of like the cost of building becomes free, then it's the quality signal. Also, when should you build versus when should you reuse? Fascinating because everybody could just use their own stuff, but then
Yeah, anyway, thank you. Thank you, Fritz. You say some words. Yeah, for the panel later. Angie?
Yeah, hi everyone. Like Fritz said, Enrico did a really good job with all the intros, so I don't have anything else to say about myself. But yeah, I'm Angie. I'm a final year PhD candidate at MIT. And I'm going to switch things up a little bit from maybe talking about how AI supports visualization and instead think a little bit about how visualization can support AI and maybe more importantly, like support us in our usage of AI. And so I've been thinking a lot about what it means for AI models to be aligned with human values, with human expectations, with our behaviors, and how visualization can support us in that. So I'm going to talk about some of the things we found and then some of the things that we're excited to think about. So I'm kind of like starting by stating the obvious, but AI models are now very much like our collaborators in the tasks that we do. When they started, like when I started my PhD, right, models are something that only AI experts ever used. You had to know what you were doing. They were like, you had to have a computer that had to run them. And now, like my grandma asks me like what ChatGPT is. So there's this aspect of lay people being involved, and then also them very much being collaborators right there. We're asking questions about our data. We're asking them to debug our code. We're asking them to like monitor things about our health and our fitness. And so as we've built these systems, there's been this idea that we're building towards human AI alignment, right? That we want AI, there's a lot of different definitions for this, but one that I like is that AI systems should abide by the goals and values of their users in society. And so far, this has largely been centered around this idea of like making models and their users more and more similar, right? So that we train our models on a bunch of data, they learn some representation of the world, of our tasks, and then we as people have our own representations of the world and our tasks, and that we're going to try to make these representations more and more similar, more and more aligned. And as a result, like this has been incredibly useful, right? Like before alignment training, your large language chatbot isn't even a chatbot, right? It's just going to try to continue what you're saying, it's not going to answer your questions. So it's made things useful. And it's also made things really safe. We can embed these sort of generalized principles like being respectful and being helpful and being harmless into our models this way. But it's very much this top-down exchange, right, where it's done by developers for users. So your model is human aligned and then released to all of us to use. But actually, when we think about human collaborations, we can actually benefit from this idea of misalignment. This panel is a great example, right? We all share some baseline care about AI and visualization, but we have different backgrounds, we work in different places, we think about different problems, and it's actually that form of misalignment that makes us interested, right? If everyone came up and gave my talk, like you'd be out here. And so this question becomes, given misalignment is so valuable, how do we leverage that in an AI scenario, right? And yeah, we see this, not just in panels, but we see this, in coding. People have different mental models of code base and they work together to build the whole application stack. We actually do this in high stakes domains too. In healthcare, we can be tumor boards where we bring in a bunch of different medical specialists and have them reconcile their ideas about disease presentation to make optimal patient care. And we see this in science all the time, right? Interdisciplinary, there's a reason we like interdisciplinary collaborations, and it's because there's some amount of misalignment. And so instead, what I've been thinking about when visualization comes in is alignment more as a communication problem or a reconciliation problem, right? Where can we support collaboration between people and their users that are going to have different representations, both because, you know, alignment is probably never going to get us all the way there, alignment training, but also because like we have different representations. So, you know, there's always going to be some amount of misalignment. And can we instead think about this as, you know, an interaction problem with our models, where visualization becomes that communication medium, right? So how can I work with an AI model? How can I understand it and use it and control it without needing its representations to be the same as my own? And so I'm going to show you two things that we've done that I think kind of point in interesting directions here. One is that we find that when you shift this idea of reconciliation, right, when you support people in understanding their models, they actually get to define what alignment means to them in context, and they can actually improve the safety and efficacy of their interactions without having to change the model, which is something that, you know, we don't always think about. We often think if we want better interactions, we need a better model, but we can actually help people in improving their interactions. And the other thing we found with this process is that we can do knowledge augmentation. We can actually learn from AI model representations when they're different from our own. We can improve our own representations of knowledge and data in doing so. And so, yeah, so one example of this is that when we give people the ability to audit and understand their models representations, they can mitigate misalignments. And so here we worked in a medical setting where the task for both like doctors and AI models is to diagnose melanoma. And one way, because people share mental models and do reconciliation all the time, is through explanation, right? So a doctor might tell someone that, you know, they know that this is melanoma because it has this irregular border. And with interpretability, AI models can give us explanations too, right? They're usually in this format, which is called a feature attribution map. It just means that whatever is really bright here on the screen is what the model is, the features the model considers important for me. And simply, like pretty simply, by just shifting these into a shared representation space so that you can directly like do this comparison, you can take a human explanation, turn it into an annotation. You can discretize AI explanation, turn it into an annotation. Now you can see overlapping like what the difference is between these two explanations. And importantly, you can quantify this, you can sort of set theoretically compare. But what I think is cool is that when we embedded this in an interface and we gave it to dermatologists on a model that was like very high performing and that they were considering using in practice, they were able to use it to better understand their model's representation. So like they had very little idea about how this model was trained, but seeing how it made explanations, they identified some failure pieces and misalignments. So here you can see that the model's relying on these sort of like green, purple, and orange artifacts that exist in these images to make the diagnosis, as opposed to the actual lesion in this example. And so, and by framing it in this way, right, in terms of what it means to reason about data in the same way, people, like, this is problematic, obviously, right? At best, we're wasting dermatologists' time. At worst, we're making incorrect diagnoses. But by seeing this, it actually gave them, it empowered them in a few different ways. So one, they were able to shift their interactions to handle this. We thought they would immediately want to throw this model out, but they had ideas about like, oh, well, it's fine. Like we can remove all these artifacts from our images. We can review cases here. And it also gave them a vocabulary to discuss what they want with their model vendor, right? So they were able to say things. Previously, it was like, well, I want my model to be good. I want my model to work, right? And now they have examples for, okay, here's what my model is reasoning differently. Here is what my expected reasoning is. Here's sort of what my level of tolerance is. And yeah, so I think by showing people their models representations, we can actually improve their interactions without actually having to make the model better necessarily. And then the other thing that we recently did that I'm excited about, and also excited to talk about, is how we can help people learn from their models. So as models are getting better and better at tasks, can we actually use visualization as a communication medium to say, here's your model's representations, and can we learn better representation ourselves? And an example of this is the WHO's International Classification of Disease is this big knowledge graph of diseases and procedures that are all broken down, and they're really important. Primarily in the US, they're used for insurance billing. So when you go to the hospital, they say, here's the things you have, here's the procedures you received, they send that to insurance. Insurance says yes, hopefully. And so the question was, we started this, we asked the question like, oh, do we classify disease in the same way? And we thought we'd be like, okay, models are doing this poorly, and maybe we'll find some issues with the models. But what we actually found was issues with that disease classification system itself. So when we had physicians look at the class of the diseases, or like the codes is what they're called, that co-occurred the most, oftentimes it'd be things that make sense, like diabetes and hypertension, right? Because if you have diabetes, you're more likely to have hypertension, and vice versa. But they also found that this thing where the most commonly applied codes were these other codes and unspecified codes, which are in the knowledge graph, totally valid, right? Like, there's nothing in the knowledge graph that says don't use these. But as people who do this all the time, they were like, if I submit these codes unspecified, insurance is going to say no, they're going to deny the claim. And so the issue here is actually not with the model, right? The model is not really doing anything invalid. The issue is that our disease classification system isn't reflective of how it's being used by people and the expectations we have, which is interesting because this is actually like a change that the WHO made separately us to increase the specificity of the specifications. But what I think is exciting is it suggests that if we understand what models are doing a task, it can actually be reflected back to us about how we might be representing knowledge in a suboptimal way. And so where do we go from here? I think there's a couple of things that are exciting. I think generally what we're trying to do here, right, is design for human amplification. We want to understand our models so that, like, such that we can control them, such that we can get the experiences we want, and we can amplify ourselves. And so I think there's a lot of interesting work on the interface side here where, thus far a lot of our interfaces are some form of a chatbot, right? Where we're not really communicating this underlying representation that a model might have. And so can we think about how we might sort of expose, the knowledge, the reasoning that a model reflects when you're actually interacting with it, right? If I'm asking Gemini here to help me with my writing, can I actually see, whose expertise is it reflecting under the hood? Whose norms is it considering? And can I interact with that so that I can change those representations towards something that I might want more closely? And then I also think it's exciting to think about using AI as a tool to reflect back to us, right? Like we just kind of saw and I just kind of talked about, can we expand that out, right? So if we have models that can diagnose melanoma better than us, can we actually not just use those to take over from what dermatologists are doing, but can we then use that to find these features or ways to diagnose melanoma that we maybe don't have now and teach them back to ourselves? And can we sort of use it reflective of ourselves, right? So as people, we have all this tacit knowledge that we can't really explain. But as we think about personalizing models, could we use them not to replicate ourselves and do all these tasks they want, but it's actually ways to teach me about the tacit implicit knowledge or behaviors that I might have about myself? And so generally, those are some of the questions that I'm interested in is how do we design for human amplification and how do we use model representations to help it?
Thank you.
Okay, so I think I may have taken a slightly different tack to my talk here. I'm going to take a very high level perspective. and talk about the changing character of data viz work in the age of AI. So here's the premise of my talk. While widespread AI adoption in the general public may be relatively new, like within the last few years, the shift in human labor that we're seeing is really not new. And so to kind of illustrate that point, I want to do kind of what Richard did and look back in history at some other fields. So let's start by talking about agriculture. If we rewind like several hundred years, humans in agriculture were laborers out in the field, toiling the soil, planting the seeds, watering, and all that stuff. And then we started to realize that this work was really hard, and we started building tools to support ourselves, starting with having livestock and plows, and then moving to more and more sophisticated agricultural machinery. And if you look at modern day tractors, they're actually, almost self-sufficient. Like you need a human equipment operator to kind of supervise and be there, but the tractor does most of the farming work. And if in modern day where we bring in AI, we can even have AIs in agriculture do more elaborate things like, plan a optimized planting layout for your farm, so on. So you could say that the role of a farmer has kind of shifted from being primarily a laborer to the modern day where they're almost like a farm manager. We can see the same kind of trend in other fields if we look at manufacturing. Rewind a few hundred years and factories were a bunch of laborers all doing manual labor to build whatever it was that we're building. And then we started to build more and more sophisticated machinery to help this, where those factory laborers became kind of equipment operators. We got steam power, we got oil power. We started to build automated factory lines and all kinds of things to help these manufacturing workers. We look at modern day factories in the age of AI, we get, very elaborate ways of working with machines. We have human robot collaboration in factories. We have factory workers who are programming the robots and supervising the robots. We have AIs who can sort of plan robot trajectories and optimize workflows, and in fact, suggest ways to make all of this more efficient, more productive. And so again, this shift has gone from laborers to something else. So what this means across many, many fields is that we're seeing a shift in labor from humans being laborers or primarily actors to now humans becoming supervisors of machinery and tools. And so my argument is that this has been going on for hundreds of years, and AI is just now like one little step further along that labor shift journey that we're seeing. So then what does this look like for visualization? Well, we rewind to the earliest visualizations. They were all hand-drawn. So these were manual labor. And a lot of modern visualizations actually are still hand-drawn. We look at some of the most creative and inspiring ones that we're seeing now. A lot of those are still hand-created by people who are fantastic artists. But along the way, now we're into sort of the 90s, we started to get tools to help us. We got computer-aided design so that people like me who can't draw could actually create things, create visualizations on the computer. We started to get traditional viz tools that automated some of this labor, so you didn't have to draw every little segment. You could pass some data and it would do some of the things automatically. And as we moved into the 2000s and 2010s, we got more and more sophisticated with that, right? We started to get smarter. We got visual analytics, where we were doing some automated processing of the data in the back end, some automated analysis. We got things like viz recommender systems, so you could be even more vague in your specification of what you wanted, and it could suggest things to you. And we got conversational analytics, where you could start to ask questions in natural language of your data and have the system generate visualizations for you. And Now we have agentic AI, which takes this a step further, allowing us to do still more of this, this sort of manual work for us. You know, now we can ask an agent to generate a whole visualization system for us, like Fritz was showing us earlier. Create a whole dashboard. So what that means is that as the humans are shifting from laborers to supervisors, and that begs the question, well, then what does it mean to be a supervisor? What kind of skills do we need to be able to succeed in this world? So what does a supervisor do? Well, they do things like define the problem, set the goals, guide skill development in members of their team, right? Of the processes and the workers in the team. They give feedback to their team members so that the team members can get better. They are ultimately responsible for decisions, and they have accountability for getting the work done and for what decisions are made. So these kind of leadership skills are what I'm seeing as the role of humans in modern day work. What does this mean for biz then? Well, I see sort of two major directions. The first one is kind of what I've been talking about, right? Data analytics work is shifting now from us doing it all by hand to us being supervisors of the work. And what that means is that there's opportunities now for us to build better technology to make these kind of human AI interaction systems better for data biz work. And this, you know, I'm doing some of this work with Enrico and with Shani Spivak, who's here in the audience, where we're looking at conversational analytics systems, where you can just ask in natural language for what you want with your data, and then have the system generate charts for you, and then you can sort of iteratively improve on them. But to make that better, we need systems to be able to have better intent understanding from that language you give it so that it can do a better job. We need the AIs to be more transparent so that when it produces a chart for you, you have an easier way to see what it did and verify those results, and then be able to repair that result if it's not quite what you want. So there's lots of challenges here still for us to address. The other direction is kind of what Angie was talking about, I think, where there's maybe a new opportunity for Viz in AI systems. You've got all these AI systems doing things for humans, but they do them often in a very opaque kind of way. So AI gives you an answer back, but how do we know how it got there, right? So we need visualization systems for AI to be able to make the model actions transparent to end users, especially end users who are not experts in AI, and to be able to sort of provide explanation and reasoning about recommendations or decisions that are being made. So my group is doing some work in this side too, especially in healthcare, where we're looking at predictive analytics tools in health use cases, and then trying to use an interface on top of that that's visual to explain those AI predictions to healthcare workers. So ultimately, I guess my thesis is, you know, AI isn't going to replace visualization designers, at least not anytime soon, but it is very much shifting the nature of data visualization work in ways that actually kind of follow a trajectory we've been on for a long time. I had to, you know, share some AI bloopers. All the images in this talk were created with AI. I love the double tractor with the guy driving it backwards. That was nice. And Claude generated this lovely contribution up on the right, which is a good reminder to us that another job of the supervisor is to recognize when your employee just isn't cutting it. So Claude got fired after this.
It's big about taste as well.
All right, so that's what I have. Thank you.
Thank you.
Very good. Thanks so much. So I'm going to ask you a few questions, and then we're going to open it up to the audience. So one question that I have for everyone is that what I've been hearing from basically all of you is about how AI is gonna help us do things better, faster, more efficiently, with less cognitive effort. But do you think that AI is gonna help us do anything original, anything new? And by that, I don't necessarily mean that the AI itself is gonna do something original, but us being able to interact with these machines are going to enable us to do something that is more, that really pushes us forward in what we do in our field.
I'll take one initial answer at this.
Yeah.
So I think I've been deliberately attempting to prompt AI for the last few years to create novel visualizations. And so the first response is if you don't formulate your prompt, the statistical machine is going to go to the center of the distribution and it's going to say no. No, you shouldn't use text in visualization. And here's all the reasons why not. So you do need to deliberately nudge it. And one of the challenges with nudging it is I have the language to talk to it about visualizations in the way that it's read about visualizations in all of its training material. If somebody in the audience does not come from a visualization background at all, they don't have the expertise to formulate the question, to have it create the thing that's novel, and it's going to land back in the center of the distribution. So there's a real challenge working with AI and being able to use and acquire the domain expertise to be able to talk to it in a way that can allow you to do something novel if you don't have that expertise.
Yeah, I would second that. That's it's so easy to sort of like let the AI do stuff that you sort of like pull yourself out of the loop. But I think right now in this very moment, I think we're still in this transition period where if you don't know the details, you don't know how to ask AI. And then you don't know how to, as you said, it gives you sort of like the statistical average. The other thing I find, at least with language models and everything, is, I mean, they don't have a world model yet. So the novel idea, in my opinion, still comes very much from a human. The thing that it enables you is like you can just test ideas faster. By testing ideas faster, you might arrive at something novel faster.
Yeah.
It's still bound to sort of like your imagination. You can just, yeah, go through more stuff, sort through more ideas faster. But yeah.
Yeah, I think that was gonna be my take, right? Like, even if the AI itself isn't very innovative, by using ChatGPT to generate charts, and yeah, I'd like to make bar charts, lots and lots of bar charts. But if you can use something like that to analyze your data really fast and get to the basics quicker, then that might give you more time to do the more creative.
As a designer, there's a really wonderful aspect of using AI. That is anybody who's writing or acting as a designer, you get kind of like a writer's block, or you got like this one or two ideas and you kind of go off down that direction and you overcommit to them too early. And you can actually ask AI, like, give me 5 different ideas, give me 10 different ideas. And it will, it will do everything. I'll happily give you 10 different ideas. And a bunch of them might be bad, but a bunch of them might be ones that you hadn't thought of because you were blocked. You already got this cognitive block and tunnel effect going in one direction. And so it actually can be really useful in a design process. I think that's one of it. I really like some of the things that you're talking about, Angie, because I can see a way there that you can use AI to become friction in a design process. So you're stopping the person from going too far, too fast down one route and saying, look, these things don't line up, or not even that they don't line up. Just here's how I'm thinking. He's like, oh, that's like completely different, right?
Yeah, I think that's where I was gonna go with it, is I think oftentimes we are benchmarking these models and like, how long can they go and do something autonomously before they need human oversight? And it's like, woohoo, like now I can send it off for 48 hours, right? Like I don't have to think about anything for 48 hours. But I feel like the benefit of AI is like, can we make us think more, right? And so that as you're collaborating on a long-term scale with AI, you're not kind of just like plateauing out with like the gains you get from efficiency of like, I can do the tasks faster, but can we actually build it so that as we move over time, you're sort of continually getting better because the collaboration is beneficial. And so, yeah, I think there's lots of ways we can think about, oh, we don't have to generate this like perfect high fidelity output the first time, right? Like, can we integrate in the design process and support the thinking, which I think is like the fun part, like to Melanie's point, right? Like, it's fun to be a supervisor because you get to set the design goals. And so how can we use it to sort of support that? I think.
Am I allowed to answer?
Of course. You're boss here. You get to take your work.
It's, I mean, I tried, I tried to prompt, my distinction would be, yes, of course, I can get a lot of work done on the data before getting to visualization, like crafting my visual representation of the stage. I can get a lot of help in getting this fast, having, different bunch of possible insights coming from the data. That's wonderful. That's great. But then my experience, and might be limited, but the knowledge AI has about data visualizations, I've been trying a lot to extract in a way what AI knows about the data visualization by prompting. My experience is that it doesn't even know all the options that are already available to represent. So I wasn't really literally not able, whatever was ChatGPT, Claude, or whatever, to reproduce all the possible, of course, unless you feed it with that. The general models, they don't have enough knowledge yet, not even to what already exists. It's not to mention if you want to be original or new. But that's my experience. I don't know if you have different experiences, but really prompted, trying to get to the, that's from famous examples of 25 different ways of doing this, 100 ways of representing that. Doesn't get to that, not even, to something that has been already done. Perhaps some different ways of crafting your visual representation of data. My experience is not yet that if you don't prompt it, but even when you prompt it with expert knowledge, doesn't get to the point we already have been able to get as humans. So that's good. I mean, but in ways for us as designers. But it's also, that's why I'm usually that contribution mostly for the first part, getting real sense of the data and what's possible to say about it, then find a way to tell that story. Maybe what is greatest insight in them. But so far, the knowledge seems to be still limited. But maybe you have a different experience.
So this is a panel. We want to have a little bit of friction.
Of course.
I'm going to push back on that. I'm going to say that, if you ask it for the list all the visualizations, it's not going to get the ones that you want because the list isn't, it's impossible to exhaust that list, right? So it's going to hit the center of the distribution and you're going to get all the most popular techniques that are listed on, like Boggust's webpage or like here, the visualization zoo or whatever, right? You're going to get the center of the distribution. On the other hand, from a creativity standpoint, these models are amazing at lateral thinking, transfer learning, right? Like you can ask for a painting in the style of whoever, and it can do that, right? Even that person never painted spaceships or whatever before. So this ability to do this lateral thinking, right, is one of the powers of human creativity. But these AI models also have this power to do this lateral thinking. So as you're exploring something from a design perspective, you can give it ideas from adjacencies, and it can help make those connections create something new.
It may help you create the connection, but not the artifact itself. So it's just, imagining that potential connection.
And then it generates the artifact, right? So as an example, one of the ones that I had was in physics and in engineering use force diagrams, right? Presses, you got forces coming all over, they have to balance each other out, otherwise it's. And I want to take that to high dimensional spaces, which is exactly what you were talking about. And how do we represent things in a high dimensional space concepts in a high-dimensional space, but use a force diagram, which isn't something that we're doing in visualization. It's not a technique that I've seen anybody do. It was able to make those connections and generate a force diagram of concepts, political concepts, rather than engineering forces, right? Because it's a high-dimensional space, you've got different concepts in a political debate. Some of those concepts are actually quite close, some of them are quite divergent. You can turn that to a 2 or 3-dimensional force diagram.
Yeah, but isn't that something that is already available that we have been doing? There's
We
not
struggle with it, like
It's
we're
not
saying,
new,
like
it's not something,
we did not, I don't think anybody has here is the high dimensional visualization that works, right? Like we all struggle with how do we understand these high dimensional spaces? And so the AI is being utilized as a tool that, well, here's yet another representation that's possible.
I think what I found anecdotally, my experience is that since it's so easy to prototype, so one thing that I used to say is that, so if you want to prototype some visualization ideas, the way I used to do it was on paper, because on paper it was faster than coding, right? But now I can actually ask Claude to do it for me, so I can prototype my ideas with code, right? And I find that even though the machine doesn't create original ideas, it helps me enormously iterate so much faster. I think you were saying something similar, Fritz, that iterating so fast makes it easier for me to explore a much larger set of options. And every time I see a new option, I have new ideas, so I get there much quicker. Right?
One question so for that example, if I sketch something, might be something that there is no word to describe. How would I describe what I'm sketching to get the prototype to translate that into code? It hasn't been codified before.
Yeah.
So I may come up easily sketching with a chart that is kind of a very Frankenstein combination of maybe a flow chart on a map with then some bar charts on top and then some. That's because I see all these potential different variables, merging into a visual, but I don't know how to call it. There is no word. There is no. How can I describe that to the machine? So then maybe the time I spent in trying to describe it, it's more than I would probably. You know what I mean? It's that's the thing that kind of is important to me. So that's what I mean. There is not enough there because I don't know how to fill that gap between what I could be able to do sketching or imagining some new forms of visualization, how to translate that into fast prototyping that I recognize, of course. Wonderful, but the moment you know how to describe it, the moment you know how to ask it, the moment you know how to prompt it. Yeah, I feel that gap, not in the data, but not getting insights, not getting ideas, but on crafting that specific new way of representing data that I had in mind that is so easy to sketch, not so easy to get on yet.
Yeah, Paolo, I think what you're saying gets to one of the points that was in the chat, that we're kind of collapsing all of our input into this sort of one-dimensional text channel, which is really, in a
that's a
way,
good idea.
limiting, right? Because you have this much nicer way of expressing your idea through sketch, and now you have to try to describe it, and that's hard.
That's right then. Maybe.
So, one thing we maybe need to work on is multimodal. Right, like what if you could sketch up your idea, feed it to your AI and be like, do something like this, but change it in these ways? Or what if you could then point at your screen and say like,
I would try
change this, change this bit, but leave the rest alone, right?
It might work.
I want to ask you one quick question before opening up to the audience. Here we are hosted by Northeastern University.
Someone succeeded with that. Like
We
if you
really-
can see that.
There we go. Nice.
So we are really concerned about how the future of teaching is going to look like with AI. And there's been a lot a lot of discussions about programming and whether teaching computer science students how to program is still relevant. By the way, I think it is very relevant. But we can ask the same question in terms of data visualization skills. What are the skills that we still really need to teach? And maybe what are the skills that we don't need to teach? Or maybe do we need to teach the same things, but in a different way? So I'm just curious to hear from you. What do you think about the educational side of it? Because that's very important for us.
I don't know, but one thing I'm really excited about is in biz courses, we like to do design studies, right? Where we ask our students to pick a problem and a data set and an end user and come up by the end of the term with a sort of fully working prototype for this application. And now maybe they can actually generate that a lot faster with using a certified coding approach with their AI. And maybe we can have those students get much, much further and deeper into their design study. They had to program everyone.
Yeah, I think it's like there's a difference between learning how to code and learning like programming abstractions, right? Like I think, when I learned to code, it wasn't, it's not actually that beneficial, but like I know R and haven't used it in like 10 years. But it was like, through this process of learning to code, you learned like the programming abstractions. And I think it's similar with biz, right? Like it's not actually like me having to read the D3 documentation for like the 10,000th time because I've forgotten once again. It's that I know the visualization representations. I know how to think about, human perception. I feel like those are the things that stay because those are the things that make us better. There's actually a really great write-up. It's called, I had to look it up. It's called The Reverse Centaur's Guide to Criticizing AI. It was a talk that was given and talks about how like a centaur is like a human brain that's benefited by a machine, right? And so we want to think about AI as a human brain that's benefited by a machine as opposed to an AI brain that we are constantly like monitoring and like it's doing the thinking. And so I think it's kind of the same way, like when we can use AI to take away, when we can keep the thinking, I think that's the goal.
I would maybe also throw out sort of like what is the goal of the course matters maybe a lot for what you want to teach. Because if it's just maybe about designing like everyday visualizations, you could maybe throw out the coding part entirely and just say whatever. But well, if you then work with like data sets in the millions, trillions, you run into problems. And if you don't know how to your point, if you don't know how to grow the AI system and even just like verbalize yourself and say like, I think this might be the issue. And you're just like, this doesn't work. Then AI will come back with the average answer and say, well, I try X. This doesn't work. I'll try it again. Still doesn't. And 2 weeks later, you're like, well, how about you try it again? And maybe at some point you get there, but we never. But then it really depends, right? And it's more like trying to teach people for something else. Like, are you focusing more on the design aspects, like the design skills, or more like stuff like how do you build software? How do you think? Yeah, a little bit mechanically, and then maybe teach the high level features and be out.
I think it shifts to more theory, less practice. It's a little bit like we shifted from assembler to higher level languages. We shifted from higher level languages to object oriented. I had to learn to do memory management. I never wanted to ever do that. Right? So there's things that are fine, right? So we've got a higher level language that we can work with. To work with that higher level language, what are the appropriate theories? We need some theories about if it's going to be computational. I need to know the computer science side of it so that I can understand how to move and manage millions or trillions of data points. That's not trivial. If it's visual, I need to be able to express those things visually. So what are the concepts? We talk about things like in our textbooks in visualization, like marks in areas and whatnot, right? Like that's not part of the language of people who don't come from visualization. So grounding that theory becomes incredibly important. So you can then manipulate it. And then do you manipulate it text or do you manipulate it with diagrams and visuals like some people have done online, right? I should be able to work with that in a modality that works for me, right? I'd be very interested in what some of the people from a physician standpoint, right? You know, people coming from biz will probably be very visual, but these physicians, I'm sure there's lots of different modalities where they can come in and the kind of tool, the kind of friction you create, those little visual diagrams are probably great for some of the practitioners, but maybe not other ones, right?
Yeah, totally. And I think like there's an education piece to that too, right? Which is that we don't all think the same way. And different modalities have different affordances and they have different affordances to different people, right? Like affordance is a function of the user. And so how we think about that communication is maybe not the same for everyone. And so far it has been the same, right? We built like one universal like health record documentation tool. And maybe that's like great for some people and it's not great for others. And I think with AI, we have more ability to do personalization, right? And to do customization. So yeah, I'm kind of excited about that aspect of it.
It's good news for universities. We can go back to teaching theory.
I'm teaching currently. You've been part of that this morning. Information design principles. I've never been happy, the principles, because those principles then will inform, your prompting, so yeah, back to the principles, and then so I want to jump on a comment that is Paul Kahn is saying, perhaps some brilliant researchers should spend time in the design studio and analysis and analyze the way mental models and communication works on. Yeah, I think it aligns with something I was thinking about. So diversity of knowledge that is embedded into these models. I think that of course, I kind of have a predominant type of knowledge that is part of it, but maybe it's my bias. But I don't think, of course, that what it knows about data visualization is probably, I would say, biased towards a certain idea of data visualization, and it's not certainly the one that I have in mind as a designer. That's my because if you look at what happens within other fields. I was looking at a project that was meant to was actually particularly modern that categorizes clothes, images of clothes, different aspects of images, and for fashion, design.
Yeah.
But so who created that way of categorizing the clothes, and then there were computer science students. What do they know about fashion design? It's not a judgment, but the knowledge they put into this taxonomy that is being created in order to have this visual, the main for visual, anyway, so this visual model to extract those features from clothes, it's driven by that kind of knowledge, not this knowledge of fashion design. So I think that is this kind of, so when the startup that we have in product design, we were working on sneakers, and then what we did, we created our own model that is both specific for sneaker. What is a sneaker? What is value in that product? And we went to sneaker designers. We understood, the way that we're working with the product, and we tried to model that into something specific. This level of specificity, I don't see is there for data visualization yet. So I don't know if it makes sense as a kind of a comment, but it's
I think it does make a lot of sense as a comment. As a designer, if I go back to my architectural background, right, probably product design, you're often thinking about exemplars, right? And they're not the middle of the distribution. They're like this really amazing bar chart, this really amazing diagram from some historical visualization or whatever, right? And you've got all of these kinds of sources of inspiration that you might be working with as a designer, you're carrying around thinking about, right? And so you've got all of these very specific instances as opposed to, as a designer, you're working with all of these pieces out on tails of the distribution, so to speak, instead of working the center of the distribution, which is where the AI is, right? So how would you work with AI so that you can just work with all the very specific bits of instances of things that you really like? And you're creating not Frankenstein, out of all of those little pieces of instances, like you were talking about the Frankenstein chart a while ago. No, it's the perfect analogy, right? But I actually want to take all of those wonderful things, but create a new, Mona Lisa, not a Frankenstein.
Absolutely.
Right? And so that becomes a really interesting way to think about, well, how do we shift? How do we think about working with AI that way?
And there are a few questions here. Maybe we should start from Erica's. I'm curious what you have learned about using AI successfully for visualization problems, tips, tricks, structured approaches.
I'll jump in then.
Yeah.
Since I've used AI to create a lot of visualizations, creating novel visualizations is, I'll ask it to do something. I used to be very specific in what I did and then let it go. Now I'm still very specific, but I'll say, before you implement it, tell me all the open questions that you have, right? So get the AI to start engaging in its explanation of how it's thinking about the problem, and what it sees as underspecified will become apparent before you've implemented something. And then it's really hard to go backwards in AI, right? So by having that kind of conversation, I find it's very useful.
Sometimes I stop the and
Yeah.
stop it.
And then, things like the data size here, here's this question, but I know the data size is going to be an issue. What are your suggestions for the data size? For example, that's again, very specific. You already know you're going to run into a problem with data size. So you're asking about that.
Yeah.
Or asking for design variants. Like I have this concept like this, I'm thinking like this. What are your suggestions before we implement anything?
I think one thing we're seeing in research is that it's not successful necessarily if you just ask a single model to build the whole data viz pipeline for you. What's maybe a little more successful is a collection of models where each one is sort of specialized to do one piece of the work, and they get pulled together into creating this final visualization for you.
Yeah, along the lines, I find a lot of old research from crowd working really interesting, because that's exactly that. The more you chop your problem into like small pieces, then AI is perfectly fine at solving small pieces. And then you just need to have a pipeline in place to put these pieces back together. And so along your lines, I would also emphasize that one thing I found most useful is almost hiding my preferences entirely, not telling what I have in mind, because if as soon as you drop a hint, and that's just priming, it's the same with humans. I asked you guys like, what pizza do you want to eat? Well, everybody's thinking about pizza and picking one type of pizza. Nobody's gonna say something. Well, some people will say I want to eat a salad, but no one is gonna come. I want to make a pie. I don't know, out of pears and whatever chickpeas. Right, because like I've already anchored you on some problem, and I feel like the very same is true for AI. And it's even worse because it then looks at the average answer is on average the best, right? And it's a statistical model that's not performing like diversity sampling. It's samples what is most commonly the answer. And if you give it some ideas, then it's just gonna fit answers back for the two things you're asking about. Like, should I do A or B? It's never gonna tell you, no, this both are trash. You should think about these three things and then come back. But if you don't include A, B, I often get better answers. Another thing I would put out there is just constrain the output space as much as possible. Sort of to the example I showed earlier, right? Like if you want production, if you want some sort of like usable thing out quickly, then you just have to chop off everything that's like esoteric and it doesn't make any sense. Then you often get much better results in practice. Like that's maybe not so great for like designing the new thing, but if you just want to use it as like a working.
So I think this is actually fundamentally a problem with agentic AI. That is, it's a non-deterministic machine. So I ask the question, and the agent executes things very nicely, and then tomorrow the agent executes things, but not exactly the same way because it's not deterministic. You're like, this can become very frustrating. Uh, And so you do need this kind of constraint, or trying to figure out ways to put constraints off, so it stays within. Student.
An alternative, or one thing that I think is helpful is, I totally agree. I think that I try to not let an AI model output the final result until I'm like very, very, very far down, convinced that that final result is correct. Because the same thing happens, right? It's like, okay, generate me an image of, a dog. And I have like some really vague notion of what that is, but then bam, I have this full high fidelity image rendering, and it's decided, the breed and the color and the background and the lighting. And so, and then you have design fixation, right? Because like now you're there. And so one thing that's been helpful for me in all sorts of prompting, but also in visualization, which is like what the question is, I don't even get to like design a visualization until I'm like very, very confident, right? It's like, oh, here's my data. Like, what would be interesting things to think about here? Or like summarize that. And I like work through I use it to work through my own thinking before I actually generate something.
You have time for one? Oh, you want to ask a question?
Oh, yeah, I don't.
Yeah, let's,
Oh, yeah, no,
Yeah.
my question's about, QA, quality assurance, on the output specifically.
Yeah.
Right, so most of us could spot the double tractor with the guy facing backwards, but I would imagine, people that are newer to the discipline, dropping data into something, asking for an output, looking at the output could be a really complex dashboard or what have you. Not as easy as spotting the double tractor, right? So how are you all doing QA on the output, and what's the recommendation to people that are getting into using these tools?
So Shani did a really nice study, actually, looking at, we generated a whole bunch of charts using the AI models, and then looked at the result, and we manually QA'd to see, was it a plausible result or not? Like, is it like the check record? There were a bunch of those, right? Like you asked for maps and it wasn't giving any maps. It would just show one chart or something. It's super easy. And then we actually went through the code and tried to find out, like, were there actually data errors along the pipeline? But there were a whole bunch. So yes, it's a huge problem. And where we're going is to try to think about, what could we expose about the pipeline that got clean data to final result that might hopefully help people to spot those problems. I don't know the solution yet, but definitely.
So you're saying exposed to the user different points along the way?
Right.
Here's how I did show my work a little bit.
Yeah, so that if it's say,
This look great, that look
if
great.
it's made a calculation, maybe you might be able to spot if there's an error in that calculation, or like filtered to a subset of countries. You could look at the list of countries filtered to and make sure it's got the right ones.
I think, like the AI pattern you have with the side panel driving visualization, you can show explicitly what the AI has toggled and flipped in all the switches it's done, either in the AI's log or it's expressed in front of you, right? So you got some ability to do some inspection there of either the creation process or the state artifact that you have. But you still have to look at that, and you'd like to ask follow-up questions the same way if you were working with the junior assistant. Did you remember to include this? Did you do just the countries in the EU officially or the countries in Europe, right? And be able to ask follow-on questions and be able to go through some of those things would be useful. And by the way, the steam-powered factory has an electric motor in the foreground. And it's not in your bloopers. So yes, you still have this requirement to inspect and understand what is there from the human is still very important in the loop there.
I'm going to give a much more AI-filled answer, which is that I find language models to be very good at critiquing the output of other language models. And so I would bet if you fed like that the electric motor into an LM, it would tell you. And so a lot of the times I think that there's two differences, right? There's like errors that just exist, like are implicitly errors, like the double tractor or like the wrong motor. And then there are like errors of expertise. So like, I think if we put all of the error catching on people, that's like burdensome and tiresome, right? And so I think the more we can catch errors automatically in like the errors that are catchable automatically, frees people up to think about the more nuanced questions, right? Like, oh, do I want Europe or do I want the EU? That's like a design choice. Whereas like, oh, I have like historically inaccurate image generation. That's an error. So I think there's like space to use AI in that error.
We are using it in that way to assess the data, right? So I have a data set. So you have a data set that you put some effort in collecting that you think is pretty good, but you can use the AI based on its training knowledge and based on its ability to do retrieval from the internet to say, is this representative for this kind of data set? What do you think is missing? And it can walk through the columns and the filters and the whatnot and say, oh, your coverage is very slim in this area, for example. So it's always been a challenge with visualization historically to, like, I only have the data that I have, but you don't see the gaps. You can actually use AI to help you see where the gaps are sometimes. So it becomes an empowerment too.
Yeah, I would maybe throw in, from my perspective, it's just strain everything as much as you can. People always talk loosely about AI, right? And I remember last time when I was here, I showed a system you just tell, hey, cluster my data, and it clusters your data. And then but it didn't. It just turned on a UI operation that says applying clustering as well.
Yeah.
It's very much constrained. That's like, it cannot hallucinate a number. It just cannot. So if you just constrain sort of like the critical things, like I would, for instance, rich AI for our systems, there is no analytic, it doesn't write Python code because then it can make up numbers, right? Which would be extremely bad. If you say, for instance, a simple constraint is, but you're only allowed to query what's already in the data. And you don't allow it to sort of like hand code or hand write D3 code. It technically cannot give you a chart where it hallucinates a number because the number is derived from a query and the query just pulls out data from a data source. It could write a wrong query, but then you see it in the chart. If you then ask, like, what is it's very simple, like sorted by most, say, an athlete's data set by most melons to be made a mistake and then sorted it the wrong way or didn't sort it. You immediately spot the mistake. But it cannot technically sort of like give you a sorted list with wrong values. And these kind of constraints, like you need to build into the system, make them fast, but also reliable. And then you can have the LLM still be sort of like the interface technology to operate it, but not like if you let it write analytics, then I feel like it gets really hairy because then everything could go wrong, right? It could write a lot of code and at the end it just inserts one number that it returns. That's it. And then you have a problem.
Yeah.
Right, I think we trying to wrap it up.
I think there's something interesting going on in the chat.
Yeah.
It's this debate whether, and I get this question a lot, so whether this automatic, let's say, production of data visualization will either increase or decrease the quality. So someone is saying that is decreasing because then people get used to those kind of standards, and someone else is saying that it may increase the quality because the people get more familiar. Maybe that is increasing kind of literacy because you get more exposed now. Some of the models they will generate probably visual stuff if you don't ask specifically, things that visual is more there now. So what do we think? Is it getting better for like the literacy level? It's an interesting because there are different answers. So that's what I like. There are different perspectives on that. But I think we're lowering.
I think it's both at the same time, right? Like on the one hand, yeah, if you just ask a LLM generate your chart, you're probably get the average type of chart. Not creative and not interesting and kind of defaults to the bars. But if you gain a little more skill in how you prompt it, it will save yourself a lot of work. And if we can build in some amount of visualization knowledge about how to use marks and channels effectively, then these systems could increase that literacy that, you know, novice users don't have to know all that stuff to be able to produce a good chart in much the way like tools like Tableau did, right? By building in some smart defaults so that you can now just pick a few data attributes, throw them on a canvas and say, create me something. And it's got enough smarts to not create you something totally dumb. Some reasonable default. And build that into these models, then we make it easier.
And in the short term before that comes out, we'll have a lot of possibly ugly visualizations. It's like early desktop publishing. Suddenly I've got access to thousands of fonts. What could I possibly do wrong?
Okay, we want to wrap up?
Sure, wrap it up. Yeah. Well, thanks so much to all our panelists. So you're going to be invited in about 1 year again. I'll thank you for, thanks so much for sharing your work with us and all your insights. This conversation needs to keep going. There's so much going on. And I also want to thank the people who attended in person and those who are online. And be on the lookout for other events that we will probably organize. You're always welcome to join again, either in person or online. Thanks so much.
Thank you, Art.
Thank you.